there's a better way. I showed it earlier. Here is that animation again. In these fusion power plant designs, when the plasma expands outwards, the pre-existing spherical electromagnetic field is waiting. By planning ahead, this field is artificially made before the fusion fuel is ignited. When the plasma tries to expand against this pre-existing field, when it pushes against this confinement field, the plasma stays hot but loses energy. When the jets move towards the confinement field, that energy is absorbed by the confinement field. The jets of hot plasma are deflected. In this symmetrical spherical geometry, deflected means pushed back inwards. The energy lost by the plasma is gained by the confinement field. In this graphic, the outer confinement field becomes a thicker blue line. This blue line represents the magnetic fields in the confinement field. Not shown are electric fields and the gravitational fields, which are also becoming stronger. This is extremely interesting. The plasma stops expanding and contracts again. I hope there are enough people out there that understand how important this is. If you think of yourself as someone interested in eliminating carbon pollution, then nothing should be more important to you than this detail. Once again, here is that animation. Again, the pre-existing electromagnetic field absorbs the energy from the expanding plasma. It becomes stronger. What does that mean? A stronger confinement field means new electricity has been made. If the pre-existing electromagnetic field has more energy, that means new electricity has been made, and this happens directly. The fusion energy is transformed directly into electricity. This detail is truly exciting. This detail is going to change the world. In the core of the power plant, when the fusion reactions happen, some mass vanishes. Tremendous amounts of nuclear energy is released. The energy from the lost mass pushes the plasma towards the confinement field and is transformed directly into electricity. That is cool. Yes, some heat will be made. Yes, this heat will be used to drive steam turbines and make some additional amounts of electricity, the old-fashioned way. However, most of the energy will be transformed directly into electricity. Again, this is a process that plasma scientists have used for about 60 years. It has an intimidating name, magnetohydrodynamics, which is abbreviated with the letters MHD. Here, we are seeing a new detail in the science of MHD. The important detail is we are creating an MHD interaction inside of a spherical geometry. In the words of plasma scientists, this would qualify as a new, innovative plasma confinement technique. In my opinion, in this detail, the study of spherical plasma confinement fields will add a few new chapters to the textbooks that cover MHD. Inside the confinement field, the fusion plasma will pulsate like this. You can easily demonstrate this for others by showing them a Hoberman sphere. Heck, I might as well just say it. Everyone, just go out and buy one of these. Buy a Hoberman sphere. Imagine that. It would be like having a mini pulsating star floating in a spherical confinement field, pulsing in and out. Each time the plasma pulses in, the temperatures and pressures in the plasma will increase, and this will make the fusion fuel burn. More fusion reactions will happen. Each time the plasma pulses out, the energy is transferred to the confinement field, and this will make new electricity. Each time the plasma pulses in, the temperatures and pressures in the plasma will increase, and this will make the fusion fuel burn. More fusion reactions will happen. Each time the plasma pulses out, the energy is transferred to the confinement field, and this will make new electricity. There are many analogies to the internal combustion engine. To save time, I'll not describe them here. The rest of the power plant is all about taking these big pulses of electricity and properly converting them into the electricity that can then be sent out over the electrical grid. Let me summarize safety. Fusion energy will be very safe. For example, imagine the spherical electromagnetic confinement field fails. This might happen if a cable from the capacitor bank shorts out. This might sound bad, but it is not. If this happens, then the hot plasma will expand and come in contact with the inner wall of the core. The hot plasma will immediately cool. This will immediately stop any fusion reactions. Yes, a failure like this could damage the core. The power plant might need to be shut down for a while until parts are replaced. However, compared to a fission power plant, there's practically no risk. Because the plasma cools, the fusion reactions stop. There's no doubt about this immediate cooling because every previous research fusion power plant design has not been able to prevent this from happening. Thus, in a fusion power plant, there is no risk of a reactor meltdown like in a nuclear fission power plant. Also, the fuel for fusion is safe. In early designs, fusion power plants will burn a type of heavy water like this. This is not dangerous. Later designs will use advanced fuels. They are also safe. A nuclear fusion power plant does not create high-level radioactive waste like a nuclear fission power plant does. The main type of radiation a fusion power plant creates is neutron radiation. The neutrons are made in the center of the core from the fusion process. These neutrons fly out of the core. They are not stopped by the confinement field. Instead, they collide with shielding materials. There's a tremendous body of scientific knowledge out there on how to shield this type of radiation. A fusion power plant will not be spewing out dangerous radiation. The neutrons will be shielded. They will be blocked. In a fusion power plant over time, if, and let me emphasize the if steel parts are close to the core, and if these steel parts are not shielded from the neutrons, then the steel parts can gradually become radioactive. However, this only creates a low-level type of radioactive waste. Obviously, this risk can be minimized with proper engineering. First, the engineers will minimize using steel parts close to the core. Actually, there's no good reason to have steel parts near the core. Second, any steel parts outside of the core will be shielded. This will minimize the chance that neutrons can make steel components radioactive. For at least 35 years, experts have been saying fusion power plants will be safe. I agree. Earlier, I mentioned a prediction made from the head of the NRC. He told me the regulatory process for the first fusion power plants will take 25 years. In my opinion, the United States must solve its energy problems as fast as is reasonable. A 25-year regulatory process is not only unreasonable, it is absurd. This is enough about these fusion power plant designs for now. The next part of this science film will explain what you need to know about the related to politics, regulations, and money. Lots of money.